Ahoy hoy, I'm Planarwalk and welcome to Sleeping Warrior Week. And for those of you who saw my teaser for what I was going to do for Sleeping Warrior Week at the end of Craig's video who were thinking, wow, that's some good acting, he actually seems like he's drunk. Well, that was because I actually was drunk. Now some people may ask, why were you drunk? Well, you see, I was actually doing an experiment to test for the spin of the Earth, and I was pretty successful. You see, I definitely felt the Earth spinning. But I'm sober now, so I don't feel it spinning anymore. Wait a second, we're talking about Sleeping Warrior and independent variables today, aren't we? Fuck. On second thought. So one of the biggest disagreements I've had with Sleeping Warrior is his definition of an independent variable. In Anthony Riley's science, the independent variable must be directly manipulated by the person performing the experiment and must be the presumed cause of the dependent variable. And if the independent variable differs from that definition, it's pseudoscience. But here's the issue of that definition. All it allows people to do is deny science, rather than actually make any progress. Being able to use that definition of an independent variable lets them say, oh, the Cavendish experiment didn't have the right sort of independent variable, therefore it's not valid. But that completely disregards the fact that we have made observations from the Cavendish experiment, and those observations have been made time and time again. It's essentially the intellectual equivalent of saying no you. But there is something that Anthony Riley fails to see throughout all of this. Why science is the way that it is. For example, I can justify why we need the peer review process. If one person runs an experiment, the results of that experiment may not necessarily be accurate. So it helps if another person comes in to run that same experiment to see if the results are the same. If the results are the same, then it is more likely that the results of the experiment are accurate to reality. However, if the results are different, then something went wrong somewhere. So that is the justification for the peer review process. As you can see, it's actually a philosophical topic. And if Anthony Riley wants to say that the independent variable has to be manipulated by the experimenter and that it has to be the cause of the dependent variable, he has to explain why philosophically. And that philosophical argument has to be better than mine, because I'm going to provide one. And I'm going to start with why the independent variable doesn't have to be the cause of the effect. So in a lot of scientific equations, you've got a whole lot of letters. For example, in some you've got F, you've got G, you've got A, you've got M, all kinds of letters, and they're not all that scary. Let's take the equation A equals F over M, which is acceleration equals force divided by mass. And let's say you wanted to verify this equation. What would be your dependent variable? So I think that in this case, everyone can agree that the dependent variable is the acceleration. So that leaves the question of what is the independent variable. Now here's where it gets tricky. Your independent variable can be force, or it can be mass. Now no matter which one you choose, there will be a relation between that independent variable and the dependent variable. Increasing the amount of force you apply will increase the acceleration. Increasing the amount of mass will decrease the acceleration. Either one of these are perfectly valid as independent variables, but neither one of them alone can account for the amount of acceleration the object experiences. Sure, you can say that force is the cause of the object accelerating, but mass isn't necessarily the cause of the object accelerating, even though it can be an independent variable. Although you could argue that mass is the cause of an object having less acceleration. More mass causes less acceleration, but less force also causes less acceleration. So it's not quite as clear cut as this one independent variable causes this dependent variable. In fact, the way that Anthony Riley words it, saying that the independent variable is the presumed cause of your effect or your dependent variable, is not a very useful way of wording it. The way that I would word it is a change in your independent variable, you presume that that will cause a change in the dependent variable. Now what this means is that you can test for relationships between two variables without your independent variable necessarily needing to be the exact cause. This means that you can make further calculations and predictions based on other things. For example, if you want to calculate the buoyant force, there's a whole lot of different variables that you need to take into consideration, such as the density of the fluid, the amount of fluid that's being displaced, and, gravity. So another example could be testing to see whether objects float in a liquid or not. So you could either have the independent variable as the density of the object, or you could have your independent variable as the density of the liquid. So a denser liquid will cause the object to float, but also a less denser object will cause that object to float. And bringing it to the main thing that Anthony Riley uses his really strict definition of an independent variable to dismiss: gravity. But more importantly, the Cavendish experiment. Because he loves to dismiss that by saying, oh, you're not actually manipulating gravity, and because you're presuming that gravity is the cause, that has to be your independent variable. However, using the independent variable that I have defined, a variable which is presumed to change the dependent variable if it is changed, we can actually use something like mass or distance as the independent variable. Now when it comes to gravity, neither mass nor distance alone are the cause. You can have mass affect the gravitational pull of something, or you can have distance affect the gravitational pull of something. Both of these work, but you have to have something else to describe the cause, and we call that something else gravity. So bringing it back to philosophy, not everything is so simple that the cause can be explained by one thing and one thing only. Therefore, your definition of an independent variable needs to be flexible enough to account for multiple causes. But next we've got the claim that the experimenter needs to directly manipulate the independent variable. Now this is just simply a way that flat earthers use to say, but you saying your independent variable is time, you can't directly manipulate time. However, I do find that there is a philosophical case to be made for time being an independent variable. And it's very simple. Time affects shit. If time is my independent variable, I can determine a relationship between something like an old banana rotting and time. In fact, if your whole experiment is to determine the rate of E. coli growing in a petri dish, time has to be your independent variable there. And I don't know about flat earthers, but time seems to affect all kinds of things, like age for example. Maybe flat earthers are Benjamin Button and it doesn't apply to them though. But even though we can't directly manipulate time, we can measure it and we can decide when we want to take data samples. If I take data samples every 5 seconds, time is not dictating that I have to take data samples every 5 seconds. I could take data samples every 7 seconds if I wanted to. I could take data samples every second if I wanted to as well. Thus, I actually have direct control over the interval in which I take data samples. And also, time can be used as an independent variable to determine whether something is going to happen at a particular time. For example, if I predict an eclipse will happen on a certain day, I can go and test that. For example, the globe model predicts that there will be a solar eclipse in December 2021. And that's actually a prediction that I'd like to go and test. So at the end of the day, when it comes down to it, you don't have to get all touchy-feely with the independent variable. Now there is the question of what definition of independent variables do scientists actually use? And I'm actually going to pin a comment on this video, if the scientist in question actually leaves a comment. In Sleeping Warrior, I'm pretty sure you remember talking to him. If you don't, here's a quick reminder.
Who am I speaking to there?
AB Science.
AB Science. So are you a science background? Do you understand how the scientific method works?
Yes.
So AB Science, a person who has studied science, who is an actual scientist, probably has more scientific knowledge than Sleeping Warrior, a person who's studying to be a lawyer. So if scientists aren't actually using the definition of an independent variable that Anthony Riley is putting forward, and are instead using something closer to my definition of an independent variable, that means that there is likely something wrong with Anthony Riley's definition of an independent variable. Because this may come as a big shock and a surprise to everyone, but scientists have actually made much more scientific progress than Anthony Riley. And my definition of an independent variable is actually based on talking to people that are actual scientists, like Professor Stick and AB Science. I actually want to challenge Anthony Riley to find a scientist who says that time can't be an independent variable and who's willing to sit down and talk with me and explain why I'm wrong about independent variables. Because I can certainly find scientists who say that time can be an independent variable and who are willing to sit down to a limited extent with Anthony Riley and explain why he's wrong. And I know that Anthony Riley might say something like, oh, that's just an appeal to authority, that's not an argument. But isn't it more likely that people that are actually doing science are using a more accurate definition of an independent variable than the people that are just, making YouTube videos? Now, a lot of this video has been making a case for the philosophy behind science. Now, Anthony Riley may be sitting at his computer going, why is this idiot talking about the philosophy? It's empirical. I mean, just look at this clip.
Do you understand that cause and effect is a deep philosophical issue, and understanding what...
No, it's not philosophical, it's empirical.
So I think it is very clear that Anthony Riley's not so much concerned about why we do things in a particular way, just that we should do things in a particular way, which ironically is very dogmatic. Well, being Anthony Riley, it probably isn't that ironic, but I digress. So a lot of what philosophy entails is, why should I do something in a particular way? Or what ought I do in a particular situation? That's where we get our morality from. So I could make a statement of murder is wrong, or I could make a statement of murder is right. Now, the justification that I give for that statement will be rooted in philosophy. So if I make the statement of murder is wrong and then I make a justification for why murder is wrong, I shouldn't murder people because I don't want anyone to murder me, I can then build a moral framework out of that. Of course, there are a lot more steps and it is more complicated than just that, but this is not a video about my moral framework. But what I can do is I can take my moral framework and apply it to real life. I can derive what I ought to do from it, and currently my moral framework works pretty well. And the same thing can be applied to science. You may have a different definition of an independent variable to me, and your definition may be more strict. Now, you've got to justify why your definition is better than my definition of an independent variable. And if you can't really justify your definition of an independent variable, then why should I use your definition of an independent variable? It's as simple as that. But here's one of the really cool things about the philosophy of science, is you can question why we do something a particular way in science. And you might actually have a good argument, a good justification for why we shouldn't do things in a particular way. And even some scientists have problems with ways things are done in science. It's not like every scientist is just part of a big hive mind that wants everything done in the same way. But if you want to question the way that things are done in science, then you have to understand that there is a basis for philosophy, especially in the scientific method. Now, I could end this video here, but so far I feel it's been a little bit too dry. I want to have some fun. So I want to introduce Riley's Rooster. So much like Schrodinger's cat is a metaphor for quantum superpositions, Riley's Rooster is a metaphor for someone arguing a position that they don't understand and then bringing up an analogy that they think will prove a point, but actually just furthers to show that they don't actually understand what they're talking about. So here's a little clip to show Riley talking about his rooster.
And I want you to tell me what's the cause in this instance. For every day for the last 10 years, there's a rooster that crows every morning before the sun rises. You make the assumption that the rooster is causing the sun to rise because every single morning the sun rises just after he finishes crowing. Don't know why, but he seems to be causing it. So you can't control the rooster crowing, but you go outside with your shotgun, you blow its head off, but the sun still rises. Was the rooster the independent variable, Craig?
So Riley's rooster. Geez, that's a bit extreme, don't you think, Riley? Blowing the head off a rooster? Could have just, drugged it or something. That's creepy though. So I'm not going to play the whole thing because it goes for a long time, but if you want to see what everyone's saying to each other, you can go check the video out. It's called Is Flat Earth a Psyop? But here's what Craig responded with.
Yes, you could say that the rooster was the independent variable, and by taking the rooster out of the equation, you have successfully concluded what the cause is not.
So that makes perfect logical sense, right? Let's see what Riley had to say about that.
So that therefore means that your rooster was not your independent variable. It didn't cause the effect of sunrise, correct?
So what was the independent variable, Riley?
You don't know. You haven't established it. You activated your null.
Okay, you tell me.
Nani?
Your independent variable is your presumed cause, right? Your null hypothesis is the opposite. It's your negative result. It's your failure. So if you activate your negative, your null, that you haven't got an independent variable because it didn't cause anything.
So I actually reached out to Sleeping Warrior because I wanted to give him the benefit of the doubt. I thought that maybe he misspoke, or maybe he said something in the heat of the moment that he didn't actually mean. But yes, he actually is this stupid. He doubled down on this shit. He pretty much thinks that if you want to test the relationship between the independent variable and the dependent variable, you go ahead and test it, and that shows that there's no relationship between your independent variable and your dependent variable. Your independent variable is no longer your independent variable. That's a lot like having an employee and you don't like his work, so you fire him. And then you say to everyone that that person never worked at your company. But let's just entertain the idea for a second that the independent variable retroactively changes to not be the independent variable because it has no relationship with the dependent variable. What if the only reason why the independent variable had no effect on the dependent variable was because of a confounding variable? So let's say that I have a hypothesis. My car can go a max speed of 60 kilometers an hour. Can't go any faster because it's a Prius. So if I have my foot full on the accelerator, it should go at 60 kilometers an hour. I can test this, right? So I get in my car, turn it on, and put my foot hard down on the accelerator, and it only goes 5 kilometers an hour. So quite clearly, there's a confounding variable. So I carry out this experiment a number of times. You know, the first time I try changing the spark plugs or something. Although I suppose it is reasonable to expect a Prius to only go 5 kilometers an hour at max speed. So let's just say that every time I carry out this experiment, the car ends up going 1 kilometer per hour faster. So quite clearly, there is a confounding variable there. So what do you think the confounding variable might be? Well, the answer is, I'm a fucking idiot, and I left my handbrake on. That's why the car was getting faster after every time I run the experiment, because it was wearing away at the brake pads. Now the whole time, my independent variable was the foot on the accelerator. My dependent variable was the speed of the car. It was what I was testing. I was still testing that independent variable to see what the relationship was. It just didn't quite match up with what I thought the relationship would be. So if my null hypothesis is met, and now I have to find another independent variable to test, like my handbrake for example, that doesn't necessarily mean that my independent variable can't again be my foot on the accelerator. It just means that in that particular case, there was a confounding variable. Simple stuff. And my independent variable certainly wasn't retroactively changed. If you want to test the relationship between two things and it turns out that there is absolutely no relationship between the two, let's say vaccines and autism, that doesn't mean that your independent variable just suddenly changes. It just goes to show that there's no relationship between your independent variable and your dependent variable. And sometimes you may have an experiment which rejects your hypothesis, confirms your null hypothesis, but actually shows a completely different relationship than you expected between your independent variable and your dependent variable. Using the car again, maybe I put it in reverse because I'm still a fucking idiot. But when it comes down to it, I think that Anthony Riley, talk to a fucking scientist. You know, there's a lot of scientists which may want to teach you about independent variables. You can ask what is an independent variable to them and they'll tell you that you're wrong about what an independent variable is. And you can try and argue it with them and they'll probably still tell you that you're wrong. And I know that he'll disagree with them because I gave him a citation on what an independent variable is and he rejected it, even though it was from an EDU link like he wanted.
You said you would accept an EDU link, right?
Sure.
Okay, so here we go.
Yeah, okay, I've seen you on Planarwalk.
It says independent variable. An independent variable is a variable you have control over, what you can choose and manipulate. It is usually
right, so
what
unless
you
you're Planner, unless you're Doc Brown, you can't manipulate time, right?
Yeah, can you let me finish? It says, it is usually what you think will affect the dependent variable. In some cases, you may not be able to manipulate the independent variable. It may be something that is already there and is fixed, something you would like to evaluate with respect to how it affects something else, the dependent variable like color, kind, time.
No, they're not independent variables. They are literally not independent variables. Color. What did you just say then? Color what?
Color, kind, time.
Right, color, kind, time are not things that you can manipulate. If that's saying that you don't have to manipulate the color, kind, time, that's not a credible citation.
Well, I could...
Oh, right. So you're deciding what the credible citation is and what actual...
So yeah, I think that sums up Anthony Riley pretty well. If he doesn't like the citation, then it's not valid. But anyway, that will be it for this video. But it won't be the end of Sleeping Warrior Week, because I shall return with another video on Sleeping Warrior. It should be a fun one. But anyway, leave a like and subscribe if you like this video. Leave a comment letting me know any examples of Riley's Rooster that you've ever seen. As always, a big shout out to my $20 Patron, What Jesus? If you want to support me financially, you can do so on Patreon. And actually, I think we have time for a little bit more of Riley's stupidity, so let's take a look.
An observation is not science.
Fuck this.